All right, today we're going to take a look at some word problems with right triangles. So whenever you're trying to work some of these out, a couple of things you want to keep in mind. You always want to draw a picture. Okay, so you always want to draw a picture, label a picture with the information given that models the problem. Then you want to set up a trig function for the equation to solve, and then you want to have obviously your answer. Okay, so those are kind of the three things that you're looking for whenever we're solving a trig word problem. Okay. First of all, before we even get started, there's a couple of things I want to talk about. Angle of elevation and angle of depression. Okay. Angle of elevation always starts at the horizontal and goes up. Okay, so elevation starts at the horizontal and goes up. Depression is the opposite way. It still starts at the horizontal, but it goes down. Okay, so take a look at these two pictures here. Over here on the left, we've got a ship and then a plane. Okay, so angle of depression from the plane down to the ship, notice that it is starting out at a horizontal and then it goes down. So this is an angle of depression. Okay, the angle of elevation from the ship up to the plane, notice that this is starting out at a horizontal and it's going up. Okay, now a couple of things to also keep in mind. Notice that these are both horizontal, so they're going to be parallel, right? So this angle of 20 degrees is actually also congruent to this angle of 20 degrees, okay? Because they are alternate interior angles. So we're going back to kind of to using still some stuff back from one of our previous modules. Okay, also over here to the right, this time we're starting out at the same horizontal line, but one time we're going up and one time we're going down. So we're showing two different angles. From this person's line of sight, that horizontal line, looking up to a plane, this is an angle of elevation. Okay. From this person's line of sight, looking down to this jog, is an angle of depression because it's starting out at the horizontal and going down. These are just good to know exactly what you're working with, because a lot of times in a word problem, they'll just reference these and you have to know what you're talking about. You have to know what these mean whenever they are referenced in a problem. So let's take a look at what we're talking about. Here we go. You're measuring the height of a tree. You stand 45 feet from the base of the tree and measure the angle of elevation from a point on the ground to the top of the tree to be 59 degrees. Find the height of the tree. Okay, so let's start from here. We want to draw a picture. So let's draw our right triangle. Oops. And let's hope it looks more like a right triangle than mine just did. Okay, let's try that again. Jeez. Here we go. Okay, well, we're going to pretend. There we go. This was on paper, it'd be perfect. All right. We're standing 45 feet from the base of the tree. So obviously this vertical piece is going to be our tree. And now we're standing 45 feet from the base of the tree. You measure the angle of elevation from a point on the ground to the top of the tree to be 59 degrees. So angle of elevation starts at the horizontal and goes up. So this angle is 59. Find the height of the tree. So we don't know the height of the tree, but that's what we want to find. So we want to find this vertical piece. Okay, so this is what I mean by saying draw and label a triangle that models the problem. Okay, so we want to draw a right triangle and then fill it out based on what the problem tells us. Now, if we take a look at what we're given, we have this angle of 59 degrees. Looking at this angle, x would be opposite, 45 is adjacent. So think about trig functions, what uses opposite and adjacent. That would be tangent. So we could write an equation, tangent of 59 equals x over 45. To solve for x, we need to multiply by 45. Now let's go over. Again, let's check. Let's see. Let's check that we are in the right mode. Yes, we are in degree mode. So I'm going to go back. So now we want to type in 45 times the tangent of 59. Hit enter. And now we know that the height of that tree, well, I should have looked at it before I clicked back over, is 74.893. And our units are feet, so it's 74.893 feet. Okay, let's try number 2. The escalator at the railway station rises 76 feet at a 30-degree angle. Find the distance D a person travels on the escalator stairs. Okay, so let's draw out our triangle. Ooh, much better this time. Okay, still not saying much. All right. It rises 76 feet at a 30-degree angle. Okay, so it rises 36 feet. So it's going up 76 feet. So we're going up 76 feet, okay, from where we were. What else? 30-degree angle. Find the distance D a person travels. Okay, so if a person is traveling on the escalator, they're traveling along the hypotenuse of this, right? So we want to find that distance. Our D is our hypotenuse. Okay, couple of things. First of all, this is a 30, 60, 90 triangle, so we don't even have to actually really do very much work. We just need to multiply 76 by 2 because 76 is a short leg multiplied by 2 to get the hypotenuse. So we know that 76 times 2 should be 152. Okay, feet. Now, let's say we forget our 30, 60, 90 rules and we want to use trig. We can still use trig. Take a look at your angle. 30, looking at angle of 30 degrees, 76 is opposite, D is hypotenuse. So sine uses opposite and hypotenuse. Sine of 30 equals opposite 76 over hypotenuse D. Remember, when your variable is on the bottom, we switch them. So D equals 76 divided by sine of 30. Let's go type that in. Okay. 76 divided by sine of 30. And notice we get 152. So either way, you can get 152 as your answer. The big thing is if you remember your 30, 60, 90 rules, that goes a lot faster. Okay, but either way, we should get 152 feet. All right, let's take a look at another one. You are measuring the height of a building. You stand 100 feet from the base of the building and measure the angle of elevation to the top of the building to be 48 degrees. Find the height of the building. Okay, let's draw a triangle. Okay, 100 feet from the base of the building. So this vertical piece is going to be our building. 100 feet away from the base, so 100 feet on the bottom. And measure the angle of elevation to the top of the building to be 48. So our angle of elevation, 48 degrees. Find the height of the building. So X is our height of the building. Now, let's see. We want to find that height. Take a look at the angle. We've got opposite is X. Adjacent is 100. Opposite and adjacent would be the tangent ratio. So we could set up an equation and say tangent of 48 equals opposite X over 100 adjacent. Got to multiply by 100 to get rid of that and solve for X. So if we go in and type in 100 times tangent of 48, we would get 111 point, what was that, 061. Okay, now let's find our units. We were in feet. Okay, so 111.061 feet. All right, let's try another one. A driveway rises 12 feet at an angle of 3.5 degrees. Estimate the length of the driveway. Okay, so we've got a long driveway. It's rising a total of 12 feet. Okay, so it's only rising 12 feet at an angle of 3.5 degrees. So that's a small angle there. Estimate the length of the driveway. Okay, so the driveway where you're driving is actually the hypotenuse, right? That would be the portion that you're driving on. So X is our hypotenuse. Let's take a look. Looking at this angle of 3.5, 12 is opposite, X is hypotenuse. What ratio uses opposite and hypotenuse? That would be sine. So sine of 3.5 equals opposite 12 over hypotenuse X. Remember, when the variable's on the bottom, we can switch those. So X equals 12 divided by sine of 3.5. Let's go type that in. 12 divided by sine of 3.5 degrees gives us 196.564. Oops, excuse me, 565, because there's an 8 after it. So x equals 196.565. And we are in feet again. So that is the length of the driveway. All right, let's keep going. Let's try some more, maybe a little bit different. You are at a parade looking up at a large balloon floating above the street. You are 60 feet from a point on the street directly beneath the balloon. To see the top of the balloon, you look up at an angle of 29 degrees. What's the height of the balloon? Okay, let's take a look here. So we're 60 feet away, and you're looking up at an angle of 29 degrees. Okay, and we want to know the height of the balloon. So x would be our vertical piece. All right, let's take a look here. Looking at angle with 29 degrees, x is opposite, 60 is adjacent. So tangent of 29 equals opposite x over adjacent 60. Multiply by 60 so we can solve for x. And then 60 times tangent of 29 gives us 33.259. And our units again are feet. Okay. Let's take a look at another one. I think we're dealing with another balloon, this time a hot air balloon. The ground crew can see a hot air balloon in the sky at an angle of elevation of 11 degrees. The pilot radios to the crew that the balloon is 950 feet above the ground. Estimate the horizontal distance of the hot air balloon from the ground crew. Okay, so let's take a look at this one. Got our triangle. Whew, that one's rough. Okay, so ground crew is looking up at the hot air balloon. So let's say our balloon is up here, and this is our little crew. These are our little guys. Okay, ground crew's here at an angle of elevation of 11 degrees. Okay, the pilot radios to the crew that the balloon is 950 feet above the ground. So this vertical piece is 950 feet. And we want to estimate the horizontal distance of the hot air balloon from the ground crew. So the horizontal is our keyword that we're looking for the bottom piece. The actual distance would be your hypotenuse, but this wants the horizontal distance. So we're looking for the bottom, which would be x. Okay, so let's take a look. Looking at our angle of 11, 950 would be, opposite, and x is adjacent. So we're using tangent again, but this one's a little bit different. We would say tangent of 11 equals opposite 950 over adjacent x. Notice our variables on the bottom with this tangent problem. So we need to switch those. X equals 950 divided by tangent of 11. So let's go put that in. 950 divided by tangent of 11. And we now know that x is 4,887 point, I didn't look at the rest, 326. Okay, and we are still in feet. So the horizontal distance is 4,887.326 feet. All right, let's go on. Let's see what we got now. Ooh, this one is a good one. We are finding some angle measures for these two. A 20-foot ladder leans against a wall so that the base of the ladder is 8 feet from the base of the wall. What angle does the ladder make with the ground? Okay, so in this case, this is our wall, this is our ladder, this is the ground. Let's see what they tell us. A 20-foot ladder, so we know that the hypotenuse is 20. Leans against the wall so that the base of the ladder is 8 feet from the base of the wall. What are our key words there? Base. So we know that we're along the bottom. Okay, so this is 8. What angle does the ladder make with the ground? So we're looking for this angle. The ladder, if you get confused about which angle, think about the two segments, the ladder and the ground. What angle do those two pieces make? It's this one on the bottom. That's our angle of elevation. Okay, so let's take a look at the angle x. 8 is adjacent and 20 is hypotenuse. So cosine uses those. Cosine of the angle x, remember the angle always goes with the trig function, is equal to adjacent over hypotenuse, 8 over 20. So remember, when we're solving for an angle, this is where we use the inverse. So we want to type in the cosine inverse of 8 over 20, and that'll give us the angle. So this is where we use our second key, second cosine, to get the cosine inverse. 8 divided by 20. And that gives us 66.422. So we know that x is 66.422 degrees. Oops, I was trying to draw a box. There we go. So 66.422 degrees is that angle. Let's try another one. We're going to find another angle in this one. A 50-meter vertical tower is braced with a cable secured at the top of the tower and tied 30 meters from the base. What angle does the cable form with the vertical tower? Okay, so let's draw our triangle. So we've got, this is the tower, vertical tower. It's easy to tell that the vertical piece is going to be the tower. It's braced with a cable. So this is our cable. And this is obviously the ground. Okay, so let's see what we got. 50-meter vertical tower, so this piece is 50 meters. Tied 30 meters from the base. The cable is tied 30 meters from the base, so this is 30 meters. Here's where our cable is tied down. Okay, let's take a look now. What angle does the cable form with the vertical tower? So that's the angle up here. And again, think about what your segments are. It says between the cable and the vertical tower. This is the cable, this is the vertical tower, this is the angle that they make up here at the top. Okay, so let's take a look at what we got. Looking at the angle x, 30 is opposite, 50 is adjacent, so we're using tangent. Tangent uses opposite and adjacent, so we can say tangent of x equals opposite 30 over adjacent 50. So in order to find x, we have to do the tangent inverse of 30 over 50. So let's go over to our calculator. We want to hit second tangent of 30 over 50, and that gives us 30.964. So now we know that this angle is 30.964 degrees. Okay. If they had asked us, for example, for the angle that the cable makes with the ground, we would have still been using tangent, but notice that we would have had 50 over 30 for that tangent because opposite of that angle would be 50 and adjacent would be 30. So it all depends on the angle that you're looking at. All right, here we go. Last two. Richard is flying a kite with a string that makes an angle of 57 degrees with the ground. If Richard is standing 100 feet from a point on the ground directly below the kite, find the length of the string. Okay, so let's take a look here. So we've got our little kite up here, okay? And Richard's standing over here, flying the kite. So let's see what we got. It makes an angle of 57 degrees. And he's standing 100 feet from a point on the ground directly below the kite. So 100 feet on the bottom. Find the length of the string. Okay, the string would be connected between Richard and the kite. So the string is our hypotenuse. So our hypotenuse is our x. So let's think about what we've got. 57-degree angle. Looking at that angle, 100 is our adjacent and x is our hypotenuse. So adjacent and hypotenuse, we're going to use cosine function. So cosine of 57 equals 100 adjacent over x, the hypotenuse. Notice our variables on the bottom, so this is where we want to switch them. So x equals 100 over cosine 57. Now we need to go type that in. 100 divided by cosine 57. And that gives us 183.608. 183.608. And let's see, that was in what, feet? Okay, so 183.608 feet of string are out for that kite. All right, last one. Okay, I already made my triangle, but let's read over the problem. An airplane rises vertically 1,000 feet over a horizontal distance of 1 mile. What is the angle of elevation of the airplane's path? Okay, so let's take a look. Rises vertically 1,000 feet. Okay, so vertical, this vertical piece is 1,000 feet, and a horizontal distance of 1 mile. So 1 mile, notice I left you a little hint here, is 5,280 feet. So 5,280 feet is our horizontal piece. Find the angle of elevation of the airplane's path. So x is our angle of elevation up to the plane. So let's see, looking at x, opposite is 1,000, adjacent is 5,280. So that is tangent. Tangent uses opposite and adjacent. So tangent of x, remember the angle always goes with the trig function. So tangent of x equals opposite 1,000 divided by adjacent 5,280. So in order to get x, we have to do the inverse tangent of 1,000 divided by 5,280. Let's go put that in. Second tangent, we get the inverse of 1,000 divided by 5,280. And that gives us 724 degrees. Okay, so that's the angle that the plane has risen at. That's the angle of elevation for that plane to have traveled a distance of 1 mile horizontally and 1,000 feet vertically. All right, guys, I hope that this has been helpful. Please keep in mind you always want to draw a picture for one like this. It helps a lot if you draw and label it so you know exactly what you're working with, and that way you know exactly what you're trying to find. We're going to go through a lot of examples and a lot of practice problems with this. Making sure your calculator is in degree mode is very important because otherwise you're going to get the wrong answer, so make sure you check that. As long as you haven't restarted it, it should still be in the same mode, but just be careful about that. Make sure you're in degree mode so that all of your answers are correct.